Today we are trying, we would focus upon Prometheus Grafana.
And introduce our next speaker. He is a cloud architect at Capgemini. Let's go ahead with the same. He is really knowledgeable person. He is giving various insights everywhere in entire India. So try to focus on the things and hope you will learn something today. So let's introduce Anish.
For SRE's rescue. Okay, so this is the topic and a brief about me. Working as a architect with Capgemini, focusing on cloud native and DevSecOps transformation. If anyone is really interested in reaching out and staying connected with me, this is my LinkedIn QR code. Please scan it and send a request and I'll be more than happy to help you out with. My session is not going to be as insightful as the other speakers did. I'm going to be a very boring session. Honestly, I'm a boring person. Let's start. Let's look at the agenda for today. We are trying to cover 3 topics: SRE, monitor and use case. So these are the 3 high-level topics which I would be covering. And feel free to interrupt me or raise your hand if you have any questions during the session. Okay, first thing first. How many of you know what SRE is? Okay, let's go to the back. Who raised hand? Okay.
So SRE is basically site reliability engineer who monitors the application 24/7. Yeah.
SRE is basically the software engineer who is taking care, making sure it's 100% system should be reliable, like 99.9% the system would be available, and he'll predict what are the things would be happen to the environment. So he taking care of those things and basically. The whatever repeated task person the team is doing, person is taking care in order to automate those things.
Thank you, Sachin and Suyog, and we have Sanket as well.
I agree with others also, and top of this, let's follow the best practices. It's more important.
Perfect. Thank you, Sanket, for adding that. One of the key aspects which we missed from the elaboration was it is not just site reliability engineering. It could be service reliability engineering as well. Any questions why we should consider service reliability as part of SRE's job? No? Aspect which would come onto your screen, most of you must have seen this feedback loop or continuous loop which talks about DevOps. There are different areas. How do we achieve DevOps? DevOps is nothing but a concept of agile way of working. We need to plan, we need to code, we need to build, we need to test, then release, deploy, operate and monitor. So these are 8 pillars in your DevOps world. But is DevOps only related to your application? Can anyone answer? Yes, you are correct. So when we talk about DevOps, there are 2 aspects. One is platform engineering, another is your application engineering, right? Platform deals with your underlying infrastructure or landscape. Application deals with how your business is going to run. So if we look at this aspect, plan, code, build, test, this is applicable for your platform as well as application. And when we talk about release, deploy, operate and monitor, this part is of SRE which needs to support either infrastructure or your application. Depending on your skill set, you need to all. And one of the questions from, sorry, I forgot your name? Sachin. He wanted to understand what observability is. So one of the key aspects would be monitor. Unless we achieve 100% monitoring on this, you cannot have 100% uptime or 99% uptime. That is depending on the enterprise agreement. That is, in SRE world, there are three core concepts: SLA, SLO, SLI. Service level agreement, which happens between your system integrator, Capgemini being one of the system integrator. So Solo, if we say Solo is an enterprise, right? And they want some activity to be done by Capgemini. There is an agreement between Solo and Capgemini. Solo defines what kind of KPIs, key performance indicators, are required by them, and that defines your SLA, SLO, SLI. Please take a note of these high level concepts. Try to read through them. I cannot deep dive into all the topics. Okay? So that is what the SRE role is. Now, talking about SRE. SRE is supposed to develop the release, manage the deployment, ensure the operations is seamless, and how they can ensure that operation or underlying infrastructure, platform or application is running. They need to have monitoring. And when we talk about monitor, there are three different areas in monitor. One would be monitoring your application or infrastructure. Second would be observability. And third would be tracing. These are three different areas which would be really important for a SRE to ensure that now since we have established or had a look at DevOps continuous improvement feedback loop, let's get into one of the CNCF major, which is Prometheus. What Prometheus is, anyone is aware of it? Okay.
Observability platform, it's one of the which you can monitor the server. It has node exporter, the kind of nodes, and you can that would fetch the data, and with that data, it would observe it fetch the node matrices, and it would give to the master node where it would print the kind of graphical way of representation, whatever the matrices of nodes which are part of that particular cluster or something.
Again, for that elaboration, let me take a step back and talk about what Prometheus is. Prometheus is again a monitoring stack which helps SRE do or achieve their KPIs. So Prometheus started way back, was incepted way back in 2012 by SoundCloud, and again, rightly mentioned, it is a platform which can help us aggregate different information which is really important for us to understand how the application or your platform is behaving. So this is the architecture of Prometheus. It all starts with the Prometheus server. And when we talk about Prometheus, Prometheus is primarily a time series database which tries to aggregate information on a timestamp, and that is what gets plotted on a graphical user interface. So there are different aspects from this. One quick question to all of you. Who would be really interested in staring at the screen 24/7? No one, right? That is where the alert manager comes into play. Prometheus provides capability to define different rules which can generate certain alerts. I'll elaborate about how that is achieved in the third section, which is use case. And there are different plugins or hooks which can be utilized to trigger alerts. Alerts could be through SMS, emails, Slack, notification, so on and so forth. So overall, this is high level architecture of what Prometheus is. Any questions before we move forward? We need a lot of aggregation to be carried out. If you have, let's say, CPU usage, telemetry information is getting aggregated. Would you just want to plot your chart per minute basis, or would you want to see a pie chart or a different chart which says that in a specific day the usage is at certain level but it goes beyond, and that is where the average functions and different count function comes into play, and that is provided by PromQL. So on the screen what you see is a snippet from Prometheus implementation which helps you understand how you can aggregate the data. So what you see over here, it talks about sort in descending, do a sum of different telemetry information and plot it. So this is the result of that. So PromQL also provides us aggregation, which is going to be really critical when you are trying to create dashboards in different GUI. And what you see over here is a Grafana dashboard. The out-of-the-box capability provided by Prometheus is very rudimentary or basic. You can only define certain charts. And Grafana is another product in its own. So Prometheus and Grafana both are part of CNCF umbrella. They provide the similar capabilities which I would be talking about, not at length, but yes, there is an option to utilize, integrate Grafana dashboards into your monitoring aspect. So you could have the different charts which are present over here. I cannot recollect different types of chart right now, but yeah, so this is what the Grafana dashboard looks like. But is this so simple to actually create dashboards in Grafana? Yes, it is, because Grafana is becoming an ecosystem in its own, which provides you different templates to plot a different chart. So there is a library. When you go to Grafana's website and search for templates, you will see different templates which can be leveraged for implementing your specific use case. So look at that when at your leisure. I'm not going to deep dive. Now let's do a apple-to-apple comparison from with Prometheus and Grafana. What Grafana is? Grafana is a product in its own. It started in 2014 after Prometheus came into play. But Grafana has moved forward and it is becoming a product on its own. It is creating different services within itself, like time series data. One of the aspects which we can think of is utilizing Prometheus as a time series data. But when we think about Grafana ecosystem, it has its own system like Grafana Cortex, which is a plugin which can be utilized for storing your time series data. And if I take a step back, one of the drawbacks of Prometheus is Prometheus doesn't provide you storage of logging capabilities, which is missing from the Prometheus, which is overcome by the Grafana. And Grafana is offering a plugin called Loki, which does the aggregation of your log information. And where would log information be required? So there are two use cases. You need to aggregate your application log. Depending on the use case, you need to extract the right information. So one of the simplest example would be, let's assume user authentication is getting logged in some flat file in the system, and there is a need for you to actually display what was the number of errors in login, validation, or what was the success ratio. Is that possible unless you bake in the right capability into your existing database? No. So that is where the aggregation of log comes in handy. You can use Loki to aggregate the log, run your algorithm to extract the information from there, and then display the information onto different dashboards. So that was all about the Grafana part, which is primarily utilizing Grafana capabilities, not Prometheus, because Prometheus has limitations of its own. So what we have done is, when we talk about an enterprise, enterprises have distributed system deployed on different servers. It could be virtual machines, it could be Kubernetes cluster, there would be involvement of your hyperscalers like AWS, Google Cloud, or Azure for that matter. So what we are doing is, we have created a tenant of Cortex and Loki. Cortex is your time series data, Loki is aggregation of your logs, and we are pulling the matrices from different systems within the landscape. And how are we achieving that? So there is a concept which I missed to elaborate upon, how the matrices or telemetry information is getting pulled from source system. So there is a concept of exporters. So I believe, sorry, I forgot your name. Sachin mentioned about the exporters like node exporters, so on and so forth. So there are multiple exporters which can be leveraged to export your telemetry information from your source system. So node exporter is primarily understanding your infrastructure, but when you need to have aggregation of your telemetry information of your application, that is where different exporters like JMX, if you have a Java implementation, can be leveraged to pull that information and plot it onto your dashboard. So what we are doing, we have the implementation has a common portal. In case there is some infrastructure that needs to be provisioned, we request that infrastructure through the portal. Once the request is raised, what it does is, it under the hood spins up the right DevSecOps implementation. So there are concepts like IAC, Terraform, which is provisioning, utilized for provisioning your application. Then Ansible, which helps you do the configuration management on the deployed infrastructure. And then the third part is your automated build, package and deploy through CI/CD. Jenkins could be leveraged, Argo CD, Circle CI. These are different tools which are part of CNCF, which can be leveraged to automate the entire life cycle of your infrastructure provisioning to deployment of your application. So once the request is raised, the right tools are invoked which deploys or provisions the right infrastructure, and based on different tool set which are defined in the auto provisioning step, right kind of agents, Grafana agents, are deployed on that infrastructure, which starts aggregating the right information, and then that information is stored in the data aggregation layer, which is multi-tenant matrices, multi-tenant logs using the right capability, and these are connected to Grafana dashboard to generate the right visualization. And as far as in case of some certain failures, there are right integration with the different tools like Jira, Slack, Teams, so on and so forth, which would inform the SRE people to take the right action. And one of the aspects is, we just spoke about the underlying infrastructure and application. We never spoke about databases, right? Database is also part of your landscape. So how do we aggregate the information from databases? There are right kind of exporters in Grafana. So MySQL exporter, Oracle exporter, these are different exporters which can be those could be visualized onto your Grafana dashboard. So this is pretty much the automation use case which we have implemented for one of the Capgemini customers. Any questions on this implementation? Yes.
Elaborate a little more about the data aggregation layer regarding the Loki.
Okay, so Loki is primarily a log aggregation layer. So I gave you a use case. Let's assume your application or one of your service is responsible for authenticating you, right? So your credentials are stored somewhere in database, but you just validate them and you do not store any information about your login into database. How can you retrieve or identify how many successful login happened in a day or a failure in the login? So one of the ways of achieving that would be you can store all the application logs into a flat file, which can be then exported into your Loki, and then right kind of algorithm could be run over that flat file, which extracts the right information. Number of successful logins, number of failed logins, that can be stored in Loki. Then the right kind of aggregation or GUI implementation could be done through Grafana. Okay? Yes, you had one question, Sachin.
Like without myself, right?
Yes. Let others also understand.
What the thing is like node X, like in the normal by the time we wanted to analyze any like node, we are using node X folder, right? So for the application in the Kubernetes, like a lot of pod are spinning up, right? So we fetch like pod logs from like we must be like pod is basically a service would be running, and for that how come like we are just doing integration for fetching the pod related logs from there?
So everything is dependent on what pod is. Nothing but a dumb box, right? Which is just spinning up your workload and executing it. So whatever extra logic, the aggregation logic is required, that has to be written in your application. So that is one way of achieving it. But if we take a step further from the Kubernetes standpoint, there is a concept of Istio, what is service mesh? Service mesh.
Okay.
Service mesh also offers similar capabilities, which does the right kind of aggregation and provides it.
Service mesh is the same product of it's not it's a kind of external thing.
Yeah. To elaborate about service mesh there are different products. Istio is one of the service mesh capability. Linkerd is another one. So Istio is primarily one of the prominent implementation in the industry, which was open sourced by Google. So what Istio does is, when we talk about Kubernetes deployment, your application gets deployed as a pod, and what service mesh does is it spins up additional pod, the concept of sidecar, which listens into all the traffic coming into the service, aggregates the information, and then publishes it on.
Sidecar container, so logic for that, right? Like it's already been there, and we are just filling up.
Yes. There are out of the box capability offered in Istio, like service discovery, your tracing, like which service is communicating with service. Those kind of aggregation are by default offered by service mesh. But if you are more interested in aggregating your application log, then you need to write external exporters. So Python could be leveraged to implement your specific use case and deployed as a container, which does its job real time. Any other questions? The next slide only talks about the Q&A part, but I am kind of finicky. I try to address the question right away. So if there are more questions, I am more than happy to address them.